Hello, everyone. Welcome to the third day of Understanding Deep Learning. This event is organized by Data, a student data science and machine learning group at the University of São Paulo. My name is Leticia. I am a computer science student and a member of Data. I'd like to thank the University of São Paulo and the Institute of Mathematical and Computer Sciences for their support and help in promoting this event, and also give a special thanks for Marzieh for accepting our invitation. We are very excited to have you here. Our speaker today, Marzieh Fadaee, is a senior research scientist at Cohere for AI, the nonprofit research lab of Cohere, where she focuses on advancing the field of natural language processing. Dr. Fadaee holds a PhD from the University of Amsterdam, where she studied neuromachine learning translation models. Before joining Cohere for AI, she was a machine learning and NLP researcher lead at Zeta Alpha Vector, where she pioneered innovative approaches to knowledge discovery and organization. Her interest in multilingual learning and improving robust models has led her to co-lead the IA Initiative, an open science project that resulted in the creation of the largest multilingual instruction dataset and the development of state-of-the-art multilingual language models. Please feel free to share questions in the chat. They will be answered at the end of the talk. Before we begin, I'd like to give a quick disclaimer for our Portuguese-speaking audience. Oi, gente, tudo bem? Essa palestra vai ser ministrada em inglês, então caso você tenha algum problema em acompanhar, não se preocupe, porque daqui dentro de algumas horas ela vai estar disponível no YouTube para vocês assistirem com legenda. Now, without further ado, let's hear Marzieh.
Hi, thanks for the warm welcome. Boa tarde. Welcome, everyone, and thanks for having me. Thanks for inviting me for today's talk. So what I'm going to be talking about, and I think everyone can see my slides, and so we should be good to go. So what I want to talk about today is why it's important to work on multilingual problems in the age of language models, and why it's also very challenging and not that many people are actively working on that. It's more today, especially the last few months, than maybe like 2 years ago, but still all of the open questions in this area. And I would also then describe what we did in the IA initiative and how we achieved building open source multilingual language models with the help of the community. And if I want to frame my talk in 3 main takeaways that I hope you get from this talk in the end. First is why we should study multilingual frameworks in general. Second is how we built the IA initiative. And lastly, the open challenges and questions in multilingual language models. So you all, like many of you, most of you speak Portuguese, I imagine, like you speak non-English languages in this audience. I don't think I have to motivate it for you guys that multilingual models matter. The world is not just built on English-speaking people, and each language can bring its own nuances and culture into the framework that we are working with in machine learning. But it's also not just so that like we can communicate with these models. Current language models are great. They are very impressive. But when you look at the history of what were the breakthroughs and the achievements that led to where we are right now with language models, many of them are rooted and grounded in the field of machine translation. So language models, way before large language models, we had language models, statistical ones, in the field of machine translation. The attention paper, so the first adding attention to local and global to RNN neural networks was to address the task of translation. The transformer paper, which is currently the architecture that all of these models are based on, was a paper in translation. Even some things like how we tokenize the inputs. The first paper on that and the follow-up papers on that, actually, they were all in the field of machine translation. And I don't think it's a random fact that this is happening. And one of the main reasons, in my opinion, is that translation is quite a complex task, because when you compare it to other NLP tasks at the time, like summarization, sentiment analysis, like these other tasks, the level of knowledge that you need to have in not even like one language, but at least two languages is quite complex, because you have to understand nuances in one language, and that can include like idioms, like there are some things that are not easily transferable to another language. And then you also have to successfully transfer that and generate in another language. And my argument is that when we work on building frameworks and building technologies to capture complex problems like translation, that's when these breakthroughs happen. That's when we have to develop impressive models, impressive technologies to be able to learn that and capture that. And this is one reason that I think is, in general, it's important to continue to working on in the multilingual framework. So not limiting ourselves to English only with the current very impressive language models. But there are also other reasons why it's important to work on multilinguality. One thing is that it's not just by adding each language, it's not just one language that can benefit from the data that you have and the model that you train. So there are situations and cases where cross-lingual transfer can happen. So if you have, for instance, if you have a lot of data in one language and you train a relatively good model on that, you don't need to add as much data for a second language to get to the similar performance on the first language. You can get away with maybe fewer data points. And if you do that right, the model can extrapolate, and this like cross-lingual transfer can happen, so that if, for instance, in a domain that you don't have data in your training data in one language, you can still answer in that language at test time. And this is important how essentially by introducing new languages to these models, it's not just that one language that benefits, but a group of languages that can benefit. But of course, this is with the caveat that it's not always the case that languages, like there are also like cases that it really depends on how you do that, and like in what scenario and what is the goal, so that you also don't encounter forgetting of the first language. So you really want to keep the knowledge and add on top of that. Another interesting aspect of it is the whole discussion on safety of language models. So when you look at how the current models are trained, a lot of the focus of safety and making these models prone to getting jailbreak is done in English. There was this study that looked at if we come up with attacks, prompts that would prompt harmful generations to these models in high resource or mid resource languages, the chance of having like a successful attack is quite low. But for the same model and same attack, we can translate them to low resource languages, and then we can, with a higher chance, we can bypass all of the safety guardrails that the model has. So it's not really a matter of like working on models being multilingual and being good at all of these languages. It's not just so that the person that communicate with this model in a low resource language can benefit from that, but it also helps with how any form of preference or guardrails that you add for your own language can be preserved in general. Like if you want to trust your model, for instance, if you want to deploy this model in a situation, like in an application that is very sensitive, like you really care about harmful generations, then you should also be able to trust that. And not being trained on a lot of languages can open the models up to get jailbreaked more often. And I keep talking about multilinguality and like how it's important, but there are a lot of complexities even in like one language. Like here is an example of for the language of Arabic, there are a lot of different varieties, different dialects, and it's very much tied also to the location. I imagine probably for Portuguese is the same, like probably the Brazilian version versus the European version. There are some nuances and differences that you can tell. So like even when we talk about a model becoming multilingual and like becoming fluent in one language, then there are all of these complexities that come after that. So really the whole problem, the whole area is quite fascinating to me, and it is quite interesting and complex to capture in the current models. And that's essentially what we set out to do last year with the AYA initiative. I'm not sure how, like if in the audience anyone is familiar with what we did with AYA and we continue to do. But this was an initiative, an open science initiative that we started last year. And our main goal was we wanted to accelerate multilingual AI progress. How we wanted to do that? We wanted to build and release in a open source and open license manner models and data artifacts and like everything that can help with building better multilingual models. And we also it was really important for us, and as a lab, it is important for us that how, where, how, and by whom ML progress is happening, and especially when we talk about like a problem like capturing multilingual or like building multilingual models. It's very important that if you want to represent a language, people that speak that language are involved in the process of building this. So for a second, I want to just take a step back and look at what is the current recipe to build a language model. We have the pre-training phase where we essentially start training a model with the goal of next token prediction using unlabeled data. So this is in an unsupervised manner, and we have like billions of data. Because it's unlabeled data, there are essentially the whole internet can be the training data for these models at this point. And you can imagine that when we talk about data in non-English languages, at this stage, we are probably still doing not so bad. Like there are Wikipedia pages in a lot of different languages. There are like news websites. And of course, not for many languages. Like there are a lot of languages that are not represented currently on the web. But going from essentially the highest resource to the lowest resource, there are a lot of languages that are well represented and can be, we can essentially pre-train a multilingual model at this point. The next phase is the instruction fine-tuning phase. So this is when we need some form of labeled data in this format of often like prompts and responses, like questions and answers. And the goal here is for the model to, like given a question, learn to generate the answer. So if before, for the next token prediction, you ask a model, what is BERT? The answers would probably be very like, just like, what is Roberta? What is like maybe like similar sentences to that original question. But here we are aligning the model to answer the question instead of coming up with the next with a similar question. Here, because we need label data, we are already at a point that we have to get that for like in a multilingual context. It's not readily available. But the good news is that we don't need billions and billions of tokens like we do at pre-training stage. And this is where we started the AYA initiative. So we aim to create data sets covering a large number of languages that are in this instruction format, and trying to build this artifact with the community. So I say community, that's a big part of it. When we think about working open science, especially this like a large scale data collection project, we didn't actually anticipate it for it to get so much attention, but people were really excited about preserving their language in these models. So we started this project on our Discord, the Cohere for AI Discord community, and we built a UI asking people to come up with these examples of prompts and answers in their own language. And we started the data collection early last year, and we did that for 8 months. And in the end, more than 3,000 contributors joined this project and added at least one example to this collection, which has been really like still very still amazing that we could really build something like this. And what we ended up covering in this collection is around 114 languages listed here. So depending on like who could join our community and like who from which part of the world we could collect this data. So let's talk about the data artifacts that we built. In this project, we ended up collecting and building and releasing two separate collections. So one is the AYA dataset, and the other is the AYA collection. And we wanted to distinguish between them because one essentially goes for high quality, fully manually curated, but at the same time smaller in size, because you can imagine that it's not like it's a very like the manual process is very time consuming and difficult. The other is acquired in some synthetic ways, which I'll explain a bit more later, like translation or templating. So kind of like a lower quality because there will be some noise in how some of the examples were generated because it's automatic. But then on the other hand, we could increase the size and scale the size because we were generating this data ourselves. So with AYA dataset, do we have the right? Yeah, I do. With AYA dataset, we ended up collecting from our contributors 200,000 examples. And I say it's small, but it's very, like when you think about all of them individually, either written or post-processed by someone who speaks that language, it's a very impressive data set. And it covers 65 languages. And another important thing that when we compare to previous to existing multilingual data sets, it is the percentage of English. You can say a data set is multilingual, but if most of it is in English, then it affects how useful it is for multilingual training. And with AYA dataset, we have only 2% English. So 98% in non-English languages released under fully permissive license. With AYA collection, like I said, we could just like go crazy with scaling the size. What we ended up doing was some of the best English data sets that we had in this like prompt and instruction, prompt and response format. We ended up translating those data sets to all of our languages. So the coverage of language is quite high. We have 114 languages in this collection, and we ended up generating 500 million examples. It's the largest instruction data set, and with 3.5% English, it's quite impressive and quite useful for multilingual learning. So what we ended up doing with these data sets and collections. So our first effort early this year was to train a model on this data set. So for that, we picked the pre-trained model, the Google MT5, that was because we wanted to do instruction fine-tuning. The main reason we looked at what is a multilingual model that has the highest coverage of languages. And MT5, even though it's not, it wasn't even at the time the latest and newest model, it does cover 101 languages, which was the highest at that point. And we fine-tuned this model on our data. And this is the IA 101 model 13B that we released early this year. So for fine-tuning this model, we use a combination of the data that we created, but also like the pre-existing data sets out there. And there were so you can also see that here, for instance, the IA data set is quite small when you compare it to the rest of the data sets in this table. But when you look at the language ratio per category of high resource, mid resource, low resource, IA dataset is actually 56% low resource languages. So having a smaller dataset but high quality in a lot of these low resource languages has shown quite beneficial for what we were doing. We also had the IA collection and then the ShareGPT command, which was a synthetic data that we created. Our main aim there was also to really pad the low resource representation. In our experiments, we ended up actually trying to see how different ratios of data per language can help or hurt the model. And we tried a few different ways of sampling from this huge collection that we had with different targets. So like one target was like the first one, for instance, we upweighted the translated data so that for even like you can see for the tail of languages, we had good representation in the training data. We also tried upweighing the templated data, which was part of the IA collection. And then lastly, we upweighted the IA dataset heavily for training. And we saw that this actually really matters, like how you sample from your collection. And the IA dataset upweighted, that was the best variant that we ran. So for evaluating this model, we looked at different tasks and different data sets. And one question was, can we actually see improvements for all languages and whether this improvement is equally distributed between different groups of languages? And to an extent, we saw that. So we did see improvements in all across the board, like high resource, mid resource, low resource. But overall, the numbers for low resource languages were on average lower than expectedly than high resource models. Still, like this performance for a lot of these low resource languages was quite impressive to get. Another study that we did, which I think is important, tying back to the data mixture that we use in training the models, was what is the role and impact of each of these subsets of data, because they are so different in how they were created and the the domains and the types of questions. So interestingly, we saw that different subsets of data in training contribute to different evaluation sets at test time. So, for instance, if you look at the middle plot, so that shows how much gain we can have by adding the translated portion of the data in the task of translation. So the Flores task is a translation task. And we see like the biggest gain by that portion, right? For like the first one, the templated data sets, many of them are on discriminative tasks, and we see the most jump actually by adding that data set. So it actually highlights how important it is when we think about building a strong model. Like, what is our use case? What do we want to evaluate it on? And that contributes to what type of data we have. I'm sorry. What type of data we have at training time. So it's not a one size fits all. It's really important to think about your particular goal and use case, what you want to do with the model in the end. Right, so that was the IA 101 model. So the next model that we developed a few months ago, I think we released it in May, was the IA 23, which is, there are a few differences with the previous models. So first of all, we changed the pre-trained model from the MT5 to the internal, the Cohere command model. So we really wanted to replace the pre-trained model with a much stronger, much up-to-date model, because a lot of gains can come from your pre-trained model. We still use kind of the same data as the ones that we use for IA 101, but we also added more synthetic data to the mix when we train this model. And in particular, this model also comes in two sizes, which was really important for us to release a smaller 8B model, because it's much more practical for developers and researchers to use. But we also released a 35B, which is expectedly a better performance model. Right, and again, for evaluation, we looked at different categories and classes of tasks, from translation to like discriminative tasks to the MMLU dataset, which is a general knowledge evaluation set. And we saw that the IA 23 models outperforms all of the models at in the same weight class at the time. So the GEMA 101, the Mistral 7B, the Bacterian model, and it also outperforms the IA 101 model. So all of these changes really contributed to having a stronger state-of-the-art model in multilingual benchmarks. So here you can also see just the win rates of different pairs of models in head-to-head open-ended generation evaluation. And the new IA 23 model outperforms all of the existing models. Right, so what we are doing now, this is a very just like a teaser. I cannot share a lot about it, but the exciting news is that we are working on the next generation of the IA models, and we will release that in a week. So we are very much at the end of developing and evaluating this model, and it's already quite an impressive model. So keep an eye out for a new IA generation in the upcoming weeks. Right, so I talked about the initiative from building data sets and then training models. And then I very briefly talked about how we evaluate these models. But I wanted to talk a bit more about evaluation in general, because it is a very important aspect of developing these models. And in general, evaluation motivates progress. If you don't have benchmarks and metrics, it's really hard to work on a problem because you need to compare where you are, whether you are going forward or backward. And it's a very like an intuitive thing, but sometimes it needs to be said, because when you look at evaluation sets in multilingual scenarios and contexts, it's not really, it's a really a hard challenge. But even in English, when we think about evaluation, it's really hard to uh, come up with just like one true evaluation set, because like what do you expect the model to do is mostly being good at everything, and that's really hard to capture in one set. There's also a challenge of uh, intentional or unintentional uh, train test contamination happening. So as soon as an evaluation set is out there, there is no guarantee that models don't use exactly them, but also uh, like rephrases and like similar questions as these sets in their training, which makes comparisons of models really difficult. So for us as a lab, it's also still important to work on, as we are developing these models, these uh, really impressive multilingual models, to also develop evaluation sets to be able to progress in this area. So first, one evaluation suite that we released early this year was uh, as part of the like AYA dataset, AYA collection. Essentially, we selected a portion of this data and released that for evaluation. So this is open-ended uh, generation task. And this set contains 3 different subsets. And depending on, again, with the compromise of if you want to increase the number of languages, then it gets harder and harder to find like native speakers and like get good quality data for all of these languages. So you have to rely on translations or automatic ways to generate them. So what we ended up doing was a subset of this data set, which is fully human curated, covers 7 languages. And then we machine translate handpicked examples, another subset, and translate that into 101 languages. And we ended up post-editing the translations in 6 languages. So a compromise of quality and quantity, essentially. And I think it's important, like ideally, if someone uses an evaluation set, I like to see numbers on both, because it tells different stories. Like one is more like focus in a few languages how you are doing, the other is like more higher coverage, but maybe there are some caveats of noise in the evaluation set. Another interesting project that we looked at was diving a little bit I'm sorry, diving a little bit deep into the MMLU dataset. So as you know, MMLU is currently very much the go-to evaluation set. It's a set of exam questions, like high school, college level exams on different topics. What we did in this project was we looked at how per different topics in this set, we use like human annotators and saw how much agreement and disagreements were between them in labeling the correct answer. And we saw a very interesting pattern that, I guess, not surprisingly, a lot of the topics with high agreement between annotators are general STEM topics. Like we have mathematics, computer science, abstract algebra, like all of these topics that are more like science focused. And then we have a lot of the topics that are social topics with high disagreement between annotators. Topics like US history, world history, professional law, philosophy. So when we think about it, it kind of makes sense. It's not, there are like some particular topics, like for instance, questions on history that, depending on who is asking that question, the answer might be a bit different. So when you want to build a multilingual data set similar to this, probably translating the whole set wouldn't really help. So that's what we ended up doing. And these are data sets that we will be releasing soon. So first, in one project, we where we did this study of like the differences between like STEM topics and social topics, we ended up selecting what we call like culture agnostic, language agnostic topics, and we translated them into 40 languages. So these are topics that are quite universal in any language and can be used to evaluate the general knowledge of a model. Let's say, like, for instance, in Persian, on mathematics, which is quite sensible. The other project that we have been working on is building a like local and culturally aware exam collection, multilingual, of course, which we did that with another community effort. So asking people in our community to find exams on topics that are specific to their own uh, country and language, like on literature, history, like law, even like driving license exams. Like these are very localized. And then we ended up processing these exams, usually in a PDF format, process them into text, and ended up covering around 50 languages that are just like very nuanced and local exams in all of these languages. So yeah, so these are two projects that we will be releasing soon. And lastly, I also want to talk about, I briefly talked about safety in the beginning. And when we talk about multilingual setting, it's really hard. There are not that many data sets out there. So as part of one of our projects, we also built this red teaming data set, which we call IA red teaming, which is a set of triggering prompts for different, I think, 9 categories of harm, like violence. There are like different categories in our list, covering 8 languages. And then we also studied how we can mitigate and make these models safer using this data set. Right. So that was the main presentation about why we should be studying multilingual problems and how we did that as a research lab. So what I want to now discuss as like parting thoughts and like food for your thought is about challenges that are still remaining in language models in general, but also like multilingual in specifically. So the first, and I think it would be like, these are very much open research questions and we need more work in these areas. First, I think is very important about factuality and truthfulness. So it's really, when you think about these models and how we are evaluating them, it's very, there are like the current way of doing that is mostly general knowledge evaluation with these data sets like MMLU, like exams. But the question of how, if a generation is factual or not, like for instance, you have like this question and then the 2 answers, you might think that during the Middle Ages, people thought the earth was flat, but no, actually by then they knew that it was not flat. So it's not so trivial, I would say, that to identify a lot of, depending on the topic, whether your model is truthful or not. And how we evaluate that is really important and an open question. The other bigger question still remains is evaluation in the sense that what are we actually, like, how should we interpret when we evaluate on these models? Like, for instance, here you see one study, the same model performs like number one on one test set and it's the last in another test set. So what does it mean? Like, how should you interpret? Like, is it good or bad? Is it the fault of the model or the evaluation set? Really, how should we evaluate these models? That's a big question that we still have to study. Red teaming and safety is still a question. I think that's something when you think about. I'm so sorry. I'm getting over a cold and I thought I was much better, but it's a little bit. Um, yeah, so when you think about things like privacy issues, like misinformation that you can generate with these models, like how to address all of these. And then when you think about multilingual, again, like misinformation in each language can be like really something really specific and different and really hard to capture. So a lot of research and open questions still to address these issues in the models. And then lastly, which is the first thing that we started this talk, is data. So we talked about how we build this data and use that, but then there are still a lot of open questions about what is the best data? Do you need a lot of that, or can you get away with less but higher quality? Synthetic versus real data, the ratios of mixtures, and also the questions of whose data are we using? Are we following good practices, licenses? These are all important questions, and like how, and there have been a lot of really nice works around all of these topics, but I think there are all still quite a lot that needs to happen in these areas as well. Right. So that's my talk. I think the key takeaways that I want everyone to have from this talk is that language models are remarkable, they're quite impressive, but there's still a lot that needs to happen to make them truly truly impressive and useful and really like practical for everyday use for everyone in the world. And when you want to represent the word in your model, I think it's important to involve the word really in in the AYA project, working with all of these people in the community. I personally realize a lot of nuances and like different, really like each language needs its own attention to the specific details, and it's really important to have insight from people who speak those languages in building these models. And then lastly, I do want to say that in general, I don't think building a multilingual model is just for like to do good to people who don't speak English. I think in general, working on multilingual framework is complex and it will help us achieve the next breakthroughs in this field. So I think that really is an important reason that we should still be studying multilingual models. I do want to give a shout out to all of the people, my collaborators on these projects. We have published papers on all of these works. The datasets and models are available on Hugging Face that you can check out. This was done not at all by just me, a lot of care and attention and love of these people behind it. And we are releasing new models soon, so keep an eye out for that as well. Thanks for your time and attention, and I'd love to hear your questions and your thoughts.
Thank you, Marzieh, for a great presentation. And now let's hear some questions. The first question is from Fernando. How have essential differences between languages been approached for multilingual LLMs? For example, false cognates, linear word order, analytic versus fusional and agglutinative languages, etc.
Yeah, that's a good question, and I'm curious to see whether your background is like computational linguistics or like linguistics in particular. So really like what you mentioned about these, like the differences between languages, if you just think about the simplest like word order, like it's really might seem simple, but when you think about like long context and then depending on the language, like it might it can become very complex to capture individual features. So what we do with at least the current models, the current generation, is relying on the model to learn these patterns from the data. So that's the main. So we don't really specifically approach individual models and individual languages and try to capture like specific features in that language. That's why the we hope that we capture that by our data. So that's why the data curation part is very important, to have examples that are representative of all of the diverse ways and both topics, but also like structures that can happen in a language. It's not fully, like I would say, like for a lot of the languages, I speak Persian, Spanish. Like when I test these models, it's not perfect. There are a lot of issues where you can just point it back to one of these features not getting captured quite well, uh, which is currently, I think, one of the open questions in multilingual models. So what we call, how to make these models more natural sounding and more fluent. Right now, these models generate data in a lot of these languages, but you can almost tell like it's not as fluent as English a lot of times. So yeah, that's a very good and open question.
Okay, so the next question is from Jesus. He said, Dr. Fadaee, how do you see the role of multilingual models in addressing linguistics bias in LLP applications, and what are some strategies to ensure more equitable technology development?
Yeah, that's a good question. So if I understand correctly, so when you talk about linguistic bias in NLP applications, so do you mean the inherent bias that these models might have, or do you mean how these models are used in different applications that have maybe some bias, which I think both is happening kind of. Uh, but yeah, so I think so for the first one, if these models, not if, these models do have uh, biases that are inherent in them, and there are ways to mitigate them. What we have seen is that targeted data generation, synthetic data generation, and fine tuning on like a small set can actually help mitigate a lot of these bias. But yeah, I think if the second interpretation of like how these models are deployed in different applications, yeah, I think that's a very like a bigger question, and I'm not sure how we should do that. But if you, so like the next part of your question is what are some strategies to ensure that the technology development is equitable? And I think that hits very close to heart to me, and I think it's important that we do that. One main contribution there is open source and open science. I think it's very important when we both data and models are open, so that helps distribute technology and makes it easier to develop on top of what someone else has built. And that's what we are hoping to that we are doing at Cohere for AI. But yeah, this is very like, I think there should be like more attention and or like action there for to make this technology even more accessible.
Yes. So the next question is from Sharmila. Thanks, Marzieh. Super insightful talk and work. LLMs being used for evidence synthesis to inform policy and decision making. Several steps still require human supervision. Do you think it always will?
I mean, if you ask me personally, and if it's about informing policy and decision making, I would say yes. I would hope that there's still some human supervision there. As much as it's easy to rely on these models to generate nice looking, professional looking pieces of text, I think it's not smart to rely uh, on these models to also be factually and like how like what you need to concern when you want to make a decision, like all of the different factors that you need to cover. It's really not smart to trust that this model will do that. So I think they can be quite useful, more than useful, like really remarkable assistance. But I think especially for important decision making processes and uh, yeah, just especially like sensitive domains and areas, we would still need human supervision.
Okay. So Fernando replied to your answer saying, it sounds like explainability and further data structures in the tokens and templates could help the model training to fine tune language differences.
I mean, that's a good take on it. So one thing that we noticed in another project is when so in this particular project we were asking a model to like giving it an example actually from the aya collection. So the aya collection is like 500 million, so it's huge. So in this project we wanted to see if we can score each example and maybe remove some of the low quality ones. And so essentially, like you have an example that we give to a model and ask it to rate the quality of this. So there are different ways to ask this question, and the best outcome that we got, so the most correlated with human judgments, was asking the model to, in addition to rating, also provides an explanation of why it's happening. So once the model was asked to generate explanation, the scores were more accurate. So like having in the context of what we are essentially having in the data, if we have an explanation or not, it does make a difference of what the model pays attention to and is learning. But it's also not so trivial and easy to create. Like if I mean, synthetic way is one way, but yeah, manual way is definitely much more complex because you are asking for uh, uh, like long pieces of text, and like from annotator's point of view, it takes more time and more effort to create that.
Um, okay, I think that's it for the questions. So thank you so much again, Marta, for your enlightening talk. We appreciate that you took your time to share some of your knowledge with us.
Yeah, thanks for having me. I actually see Fernando says that he's a mathematician, so that's very like your questions were very interesting. Um,
Uh-huh.
Thanks for having me. It was really lovely, and I just want to yeah say if you are interested in the work that we do, reach out about the research that we do. We are working on a lot of collaborations also. So yeah, feel free to reach out if you are interested in a project. And I wish you all luck and thanks for having me today.
Thank you. Bye.
Bye.